Good day everyone. I think 8.3 marks a bit of a change in this chapter because the first two paragraphs were all about calculating volumes. From now on, the last three are more about enlargements, and that's also what this chapter is called after. And the first theory that I'm going to discuss is going to be quite, not really lengthy, but has a lot of new terms that you have to know before we can really start talking about enlargement. So that's what I'm going to do in this theory. Theory A, scale factors. Some of you might have already know what scale factors are, because we use them, for example, when we're talking about models, right? Me as an architect, for example, if we had models of buildings, we used scale factors as well. Then we said, well, for example, my building maquette or my building model is on a scale of 1 to 100, for example. Or here they say the model of an Airbus airplane is to the scale 1 of 60. That means that the actual dimensions, so in real life, are 60 times as large as in the model's dimension. Then we say the scale factor, mijn vergrotingsfactor, is 60. It becomes 60 times as large. So my scale factor can be positive. For example, here on the right, we have a scale factor of 1.5 being applied to this figure right here. That means every dimension, every line in this module is going to be 1.5 times as big right here. And you can see that clearly. For example, from B to D was 2 centimeters, 1.5 times as big. This is now 3 centimeters. But all the other lines from C to D, from A to D, from A to B are all now 1.5 times as long. We call the original figure the object, het origineel. And we call the new thing the image, het beeld. So my object was here, and after I've applied my scale factor, I get my image right here, which is 1.5 times as big. Sometimes we have what we call a scale factor that's smaller than 1. And that's why I like the English name scale factor more than the Dutch name vergrotingsfactor. Want een vergrotingsfactor laat je denken dat een vergroting, dat is altijd vergroot. Well, it doesn't have to. A scale factor can also shrink certain figures. Here, my object, mijn origineel, waar ik mee begon, after I've applied my scale factor, everything becomes times 3 as small. 3 times as small. So you multiply each side with times 1/3. That's the same thing, right? So this side was 1, 2, 3, 4, 5, 6 centimeters long. After I've applied my scale factor, it's only 2. And that's the same for my other edges as well. So a scale factor can either really enlarge something or shrink something. If my scale factor is bigger than 1, it's going to enlarge it. If it's smaller than 1, it's going to shrink. And scale factor can never be negative. It can be between 0 and 1 to shrink, but not negative. As shown above, a scale factor for enlargements can be smaller than 1. Yeah, that's just what I said. When enlarging, the object and the image are always the same shape. We say the object and image are similar shapes. Or in Dutch, if you like, vormig. Ze houden dezelfde vorm. They only are being enlarged or sometimes being shrunk, right? But they don't change shape. This line is still a straight line here. And all the lines are the same, on the same place, you could say. The same way are they connected than they were first. For example, if I now d prime or d accents is not here, but for example here, then I have a completely different form. Then it's not an enlargement anymore, and it's not going to be applied with a scale factor. Okay, so this first theory is all about understanding those terms. Get those mentally available to you, learn them, because you need them a lot in the remaining 3 chapters, or paragraphs, sorry. In the remaining 3 paragraphs. Okay, there are only 2 exercises for this theory, 26 and 27. Try them. I think I will maybe do an extra exercise on YouTube as well. I think about doing 26. So if you have difficulties understanding this, please watch that video as well. Good luck.